Welcome back to part 3 of our 5-part series. Today we're covering the science most people don't expect: how melting ice can actually move solid rock, triggering earthquakes, and in some places, volcanic eruptions. In Iceland, volcanic eruption rates climbed up to 100 times higher once the glaciers covering the region retreated at the end of the last ice age. That's not a typo. This isn't speculation or science fiction. It's measured physics. Scientists have understood a version of this connection since the 1970s, and new research keeps confirming and expanding exactly how it works. So how does melting ice actually move solid rock, thousands of feet underground? Let's start with the basic physics. It starts with something simple: weight. Glaciers are almost unimaginably heavy. A single cubic mile of glacial ice weighs roughly 4.6 billion tons, and major ice sheets stretch for thousands of cubic miles at once. That weight presses Earth's crust downward, the same way a mattress compresses under a heavy sleeper. The land beneath a major ice sheet is literally pushed down over time. Scientists call this process glacial isostatic adjustment, or GIA. When the ice melts, the crust doesn't spring back instantly. It slowly rebounds, sometimes over thousands of years. Here's the remarkable part. Parts of Scandinavia and North America are still physically rising today, from ice sheets that finished melting over 11,000 years ago. The rebound is that slow. As the crust flexes back into place, it changes stress fields deep within the rock, including on fault lines that were already sitting under pressure, just waiting for a trigger. So what happens when that changing stress meets a fault line? We now have direct, peer-reviewed evidence. Colorado State University researchers found that the Sangre de Cristo fault system in Colorado slipped 5 times more often after Ice Age glaciers melted off the mountains above it. For millennia, the sheer weight of glacial ice had been clamping that fault shut, suppressing movement, until the ice disappeared and the fault was finally free to slip. In Alaska, glacial retreat is estimated to have added up to 0.3 megapascals of stress to the Fairweather Fault before it ruptured in a magnitude 7.8 earthquake in 1958. Scandinavia saw something even larger. Between 11,000 and 7,000 years ago, post-glacial rebound there triggered earthquakes exceeding magnitude 8.0. Even the New Madrid fault system in the central United States, far from any tectonic plate boundary, may be subtly affected. A 2025 study found glacial rebound can add stress to pre-existing weak zones there. An honest caveat here: researchers are clear that tectonics and deep mantle flow remain far more important than glacial rebound for most earthquakes. This is a real, measurable, but secondary factor. But earthquakes are only half of this story. The same physics reaches somewhere even more explosive. 245 of the world's active volcanoes currently sit within 3 miles of glacial ice. That's the scale of what we're talking about. Iceland has known about this connection since the 1970s, when scientists first identified a clear link between retreating glacier there and increased volcanic activity. Geologists describe the physics like this: it's just like opening a shaken soda bottle. The weight of glacial ice keeps gas dissolved in magma under pressure. Remove that weight and the pressure releases. A brand new 2025 study found the exact same pattern in Chile's Patagonian volcanoes. The first time this had been confirmed in a continental volcanic system, not just an island like Iceland. The magma itself changes too. As pressure releases, its composition shifts and becomes more viscous, which makes eruptions more explosive when they do happen, not just more frequent. And this isn't only ancient history. Magma generation beneath Iceland is already increasing today, tied directly to glaciers that are melting right now, in real time. One volcano shows just how far this reaches. Iceland's Askja has been completely ice-free for 10,000 years, and it's still rebounding today from pressure changes tied to glacial retreat happening across the wider region. So where might this matter next? Researchers have one region squarely in their sights. Antarctica has its own ice-covered volcanoes. Researchers say the same mechanism observed in Iceland and Chile could plausibly apply there too, as its ice sheets continue retreating. Scientists specifically flagged parts of North America, New Zealand and Russia as regions warranting closer scientific attention going forward. To be clear, this is a forward-looking risk assessment, not a claim that eruptions are imminent. It's really an argument for monitoring regions that may have been underestimated. There's a feedback loop hiding here too. Increased volcanic activity releases carbon dioxide of its own, a small but real feedback layered right on top of everything else we've covered in this series. Now, let's be really clear about what this science isn't saying, because this is exactly the kind of finding that gets exaggerated online. Climate change does not cause most earthquakes or eruptions. Plate tectonics remains the dominant driver of seismic and volcanic activity worldwide, by a wide margin. This effect is concentrated, not global. It shows up specifically in regions with retreating glaciers, not as some worldwide surge in seismic or volcanic activity everywhere at once. In most documented cases, this effect mostly advances the timing of events already building toward release, rather than creating brand new risk out of nothing. And again, this isn't new or fringe science. It's been studied and published in peer-reviewed geology journals for over 50 years and continues to be actively refined by researchers today. So why bring this up now, instead of leaving it in the history books? Because today's glaciers are melting far faster than the retreat that triggered these historical events. What once took thousands of years is now unfolding on the scale of decades. And we can now track this in real time. GPS networks and LiDAR mapping let scientists measure ground rebound and fault movement as it happens, instead of only reconstructing it after the fact. The real goal now is forecasting, not just explaining history. Researchers are working to build this into hazard models for glacier-covered regions, moving from hindsight toward genuine early warning. Let's pull it all together. 5 times how much more that Colorado fault slipped once the ice suppressing it melted away. 245 active volcanoes sitting within 3 miles of ice worldwide right now. 2 different hazards, earthquakes and volcanic eruptions, sharing one physical cause. Melting ice changes the weight and stress on Earth's crust, and both faults and magma chambers respond. Which raises the question we're covering next. If melting ice can reach this deep into the physical world, what does all of this actually cost, and who ends up paying for it? As always, a new video every 5 days. Part 4. The price you pay. How heat waves, food prices, and health all trace back to this data. Part 5. The business of climate change. Trillions of dollars in economic risk and what actually works to reduce it. Thanks for watching this deep dive into the science linking melting ice to the ground beneath us. Subscribe so you don't miss Part 4, out in 5 days, and let me know in the comments which fact surprised you most.